Hi, in this video, we're going to talk about graphing your basic functions. Sometimes these are also called parent functions. And these are just your basic types of functions that we see a lot in mathematics. And you just want to have a general idea of how these look and how you would graph them. So let's just go through a few of these examples. So obviously you've got your first one, which is your linear. Your horizontal lines will always have this y equals a, where a is some number. In this example here, this is y equals 2. So we just have the horizontal line going across that is hitting the y-axis at 2, and the equation for that would be y equals 2. Your vertical lines are always going to have x equals a being a number. In this example here, we have x equals -3. You can see that vertical line is hitting the x-axis at -3. And then down here, we have our y equals mx plus b, okay, which is most of the lines that you see that have a slope and a y-intercept. This example here is y equals 2x plus 3, where it has a slope of 2 and a y-intercept of 3. And these would all be considered your linear types of graphs. Now, if you go down here, these are our power, or sometimes called polynomial graphs. And there's a lot of different versions of these, but the two that we will use the most will be y equals x squared, okay, and this is what we call a quadratic, okay, and this one over here is y equals x cubed, and we call this one a cubic. So you can see here your quadratic always has that U shape, okay, and your cubic, I kind of think of it as like a little sideways type S type shape. It just has a little bit of a curve in the middle of it. Once again, there are a lot of these. These are just two examples that we're going to see a lot. And you just want to be able to recognize a quadratic or a cubic when you see one. So your rational, also sometimes called reciprocal, will look like these, okay? This first one here is y equals 1 over x, okay? And what we have on these is we have an asymptote, a vertical asymptote. So on this particular one, this first one, we have a vertical asymptote coming through here like this. And that vertical asymptote is x equals 0. And you can see that's kind of dividing that graph in half into two parts. On this one, we also have a horizontal asymptote, which would be y equals 0. And you can see that is kind of steering the graph off to the left and the right, okay? Now this second one here is y equals 1 over x squared. So you can see it looks a lot like the one we just did, except for both of the curves are on the top part of the axis. We still have this vertical asymptote here at x equals 0, and we still have a horizontal asymptote coming across here of y equals 0. But once again, both of the curves are up on the top part of the axis, okay? So, like I said, a lot of these as well, but these are just your two basic ones. All right, radical, we have two versions that we're going to see a lot. We're going to have y equals the square root of x, which will be this first one here. And you can see it's really important to notice that it stops at 0, 0. So like our domain on this one, we would have a bracket 0 to infinity. So the point 0, 0 is on the graph, okay, but there's no points to the left of that. And that's because when you're taking the square root of a negative number, right, we've seen this already, if we have the square root of, say, -4, we know that this is 2i, okay? And this is, an imaginary number. that we can't actually plot on an XY axis like what we're working with here. So we have to make sure that all of our X values that we use are not negative. So we can have 0, 1, 2, anything, positive, right? So we want to make sure that we are only using X values that fit that domain, all right? Now, when you come to the second one here, we have the cube root. I take not cubic, cubic was up above, cube root function. Now, in this one, you can see it's kind of like if you take the square root function that we just talked about, so let's label that, by the way, square root, okay? And then this one here would be the cubic root or cube root, okay? However you want to think of that. I think most people would say cube, so let me just write it that way. And if you take the square root and you just sort of add another side to it across, flip it and add it to the other side of the axis, you would have this cube root function. Okay, now our domain on a cube root function is negative infinity to positive infinity because you can take the cube root of negative numbers, okay, right? If I have the cube root of negative 8, that is negative 2. So we don't get that same result, that imaginary number, like we did with our square roots when we use a negative up underneath the cube root. So that's why our domain, we can have negatives, we can have 0, we can have positives. You have a different look to that graph. Okay, we have our absolute value here, which is obviously going to have those absolute value bars in it. And no matter what value you plug in for X, you get that positive result, okay, from the absolute value. And then as we progress in the semester, we're going to get into our exponential and logarithmic. Both of these first ones are the exponential, and this first one is y equals 2 to the x. So the x is the exponent, okay, the variable is the exponent. Whereas this one is also exponential. It would be y equals 1/2 to the x, okay? So these are both considered exponential. The base is 2 and the base is 1/2. Those are different, which is changing the look of that function. This is what we would call exponential growth because it is increasing as it progresses, the x values get larger. And then this one is considered exponential decay because as the x values get larger, the output values get smaller. All right, and this last one here is our logarithmic graph, and we will do more with this as we get further along this semester. And this would be y equals log of x. That's a base 10 log. And like I said, this is just an example of how those look, so they could just be on your radar. And you can see that this guy right here is heading south pretty quickly here. And we actually have a vertical asymptote at x equals 0, since we talked about the vertical asymptotes earlier. So you have a vertical asymptote coming across here. Okay, and so it's sort of sending that graph down pretty quickly there as it's getting close, the x values are getting close to 0. Okay, so all of these graphs are graphs that you want to memorize, and you just want to have a general idea of how they look. You also want to be able to graph functions that, have these properties to them. And we will talk about that a little bit more as we progress this semester.